All right, so we are finishing 5.6 today. If you remember the other class, we did 2 problems like this. Was this the day we watched basketball?
Yeah.
Yeah, so we did 2 of them like it. We did 2 law of cosines where we had side, angle, side, and then we had one that we had side, side, side. We have another one that is not set up nicely, so we're going to do kind of, I think, the hardest way of solving today. But then we're going to do some more easy law of sines, law of cosines, a few word problems, and then that's going to be today. So we're finishing up chapter 5 right now. So let's start by drawing a picture. So I'm going to draw a picture of this example. I do not care how you label this picture. I've got C, and I think I've got A and B. So C is 57, little c is 11, and then little b is 10. Okay. We actually are not in a place to do law of sines. We want to do law of cosines, but this one is kind of ugly, and I would not think to use law of sines here, or law of cosines, excuse me, except for the fact that it's on my law of cosines sheet. I need to find this missing side, and in order to do so, we are still going to use our law of cosines, but my side that is by itself is going to be 11, and the angle that's by itself is going to be 57. So we can call these like little c and big C, and we can call this little b and little a. So little a is the variable that we do not have now. If you remember from your law of cosines sheet, you probably have it on your paper. I feel like it's been like forever since we as a class have done it. But I'm going to use the one that has c squared by itself. So I'm going to do c squared equals a squared plus b squared minus 2 times a times b times cosine of c. C squared equals 1. So I'm going to use that one. So in this case, c squared is 11. So I'm going to do 11 squared equals, I do not know a squared, so that's going to be my variable. B squared goes for 10. 2 times a, which I don't know, times 10 times cosine of big C, which is 57. The reason this is going to be annoying and taxing is we're going to have to use quadratic formula at some point because I have an a squared and I have an a, so I'm going to have to solve it using quadratics. But it's not going to be too tough once we start going. So let's start simplifying. I know 11 squared is going to be 121 equals a squared plus 10 squared is 100. And then I can do 2 times 10 times cosine of 57 all in the calculator. It's just going to be followed by an a. So 2 times 10 times cosine of 57. And I get 10.9. So minus 10.9a. Anytime you have an a squared, x squared, or a variable squared, and then a variable without a square, excuse me, we're going to look to do quadratic formula or factoring. The reason I'm not going to factor here is because I've got 10.9, which is not going to be an easy factoring. So I'd rather not do that one. So let's move everything to one side. I'm going to minus my 121 from both sides, and then I'm going to order it in the right way. So I'm going to do my a squared first, then my a, then my constant. So 0 equals a squared minus 10.9a minus 21, because 100 minus 121 is just 21. Anybody concerns yet? Okay, I'm going to do quadratic formula now. And the reason I know that is there's no other way to solve for a. So I'm going to do quadratic formula. My a is going to be 1, my b is going to be negative 10.9, and my c is going to be negative 21. Okay. And because of the way I'm going to solve this, I'm going to put most of it kind of into the calculator in one foul swoop. So negative b, negative of negative 10.9 is 10.9, plus or minus square root of negative 10.9 squared minus 4 times 1 times 21, negative 21, ooh, all over 2 times 1. Big mistake I've seen in the past is we do negative 10.9 squared without any parentheses, and then you get a negative number and you just blindly use it. Remember that any number squared is going to be positive. So I know that I can just do 10.9 squared, okay? And I'm going to do, so that's 118.81, and now I'm going to do negative 4 times 1 times negative 21, which is 84. So I'm going to add those two numbers together. So 118.81 plus 84. So this was a minus, and then this was a minus. So when I put it in my calculator, see how I put -1 times, or -4 times 1 times -21?
Oh, negative, or 21 was negative.
21 was negative. You could in your calculator just do 4 times 1 times -21 and know that you have to minus whatever comes out of there. I just take my negative with me and I multiply all those together and then I just plus them. All right, so now I've got 202.81. That's all under the radical. So let's just do the radical of that, which is 14.24. Okay, now I'm at a place that I want to write this down. So I've got 10.9 plus or minus 14.24 all over 2. Ooh, that was way too big of an eraser. All right, now since I've got plus or minus, I need to do both plus or minus. So I got to do 10.9 plus 14.24 and then divide that by 2. So I get 12.57. And then I have to do 10.9 minus 14.24 all divided by 2. And I get negative 1.67. And now it's kind of like the human what makes sense check. If those are my two answers, what is going to make sense as a side length? The 12 number, the positive number, 12.57. So we just did a lot of work to find one side length. I have to find the other two angles though, and then I'm fully done with this. I believe the first angle we find will be like the second hardest thing we did. I think the law of cosines is the hardest. We do need to use law of sines at least. You could use law of cosines, but I just find that like to be a lot of work that's not needed. So I'm going to do law of sines. Do you guys care if we find A or B? Does it matter to you? Okay, let's find B because that was the problem that was given to us. And that way, if we messed up for some reason on 12.57, then we're at least not messing up in the next part. So I'm going to do law of sine. Sine of 57 over 11 equals sine of big B over 10. Cross multiply and solve. I get 11 sine big B equals 10 times sine 57. I'm going to divide by 11 and then I'll do inverse sine. So 10 sine 57 divided by 11. And then second sine of that is going to be 49.6 or 0.7. 49.7 is the best answer. Okay. All right, 49.7 is going to be angle B. And then we can pretty easily find angle A. Just add them up and minus from 180, right? Okay, 180 minus 57 minus 49.7, and I get 73.3. So now that we've done law of sines enough, and now that we did that harder law of cosines, I feel like law of sines feels like so easy. And we're going to do some more basic law of cosines, and hopefully that will feel easier today too, now that we've kind of done a lot of these. You good to game? Okay. All right, what questions do we have so far? Anybody, anything? 73.3, yeah. Okay, pull your identity sheet out because we are for real today going to write the last thing on your identity sheet. The last thing on your identity sheet is going to, nope, not law of tan. It's just this green thing right here. A equals 1/2 little a little b sine big C. A equals, that's it. I don't know if you noticed, this was on the identity sheet I gave you for your quiz last week, but you might not have noticed because you were only worried about your half angles and double angles. But if you were looking around, you're like, huh, we haven't learned that yet. Well, we're learning it today. What that means is we know area is 1/2 base times height of a triangle. Another way to do area of a triangle is doing 1/2 times the two sides and then sine of its included angle. Sine of its included angle. Okay. Everybody have that written down? Sometimes it's going to be so simple that it gives us those three things and we just plug it in and we move along. And sometimes we might need to use law of sines or law of cosines to find something and then use this. But this is when we're doing area of a triangle. Okay, I'm going to go write it on my other sheet. Does anyone have any questions yet? Okay. Come back. Okay. Oh, I guess it's all written here. Let me erase this page. Okay. So like I said, the area of a triangle is going to be I can't use that. 1/2 little a, little b, sine big C. Now, it may not have to be those exact letters, but we're going to notice something in a second. So let's look at the next problem, 2a. We're going to set that up. We're going to draw a picture, and then we're going to decide how we're going to use the example that, or the equation I gave you. So angle A is 47 degrees, little b is 32 degrees, and little c is 19 degrees. Okay. If you notice in this first example, I did not give you little a and big C. I gave you little c and I gave you big A instead. What happens here is it doesn't matter what letters I gave you. You could kind of rearrange this whatever you want it to be. But at the end of the day, I need the two sides and I need the angle between it. So A and B are just any two sides. And then big C is just not one of those angles. It's whatever that third angle is, which would be the included one. So that's kind of what you can think in your head as you're deciding whether this works. So 1/2 of two sides and then their included angle. So I don't have to find anything. I'm good. I'm just going to set it up, plug it in, and solve. So I'm going to do A equals 1/2 of 32 times 19 times sine of 47. The cool part about this is you can just plug that into the calculator and go. What I like to do personally is I like to simplify that 1/2. I like to do, okay, 1/2 of 32 is going to be 16. What you cannot do is you guys love to share and you're like, oh, we have to distribute, share, give it to everything. Don't do it. It only gets to be done one time. And I did it to 32. But what you could also do is do it all in the calculator in one step. You can do 0.5 times 32 times 19 times sine of 47. And that's going to be the same answer as I get when I had already simplified my 1/2 and 32 and do 16 times 19 times sine 47. We get the exact same answer either way, 222.3. A equals 222.3. Hi, Jake.
I was gonna come do my test track.
That's fine. You're fine.
Sit over here.
And that is in feet squared. Squared. Okay, we good with that? Okay, go draw your next triangle. And I'm going to tell you, we either are going to need to use law of sine or law of cosine to figure that out. So you need to decide which one we need to use, law of sine or law of cosine. Is this the one you already started, Jake?
No, I finished that other one.
Okay.
So,
And I haven't given you this one yet.
I already lost that.
Oh no. That was a good one.
It was a good run.
All right, so did you draw your circle, your triangle? Which law am I going to have to use to find something that's missing? Law of sine, very good. What are you going to find with law of sine? Little a. Is that what you said? Big B is over here. We can find either side. It truly doesn't matter if you want to find little c or if you want to find little a. Before I find either of those, though, I do need to find this missing angle. What's that missing angle going to be? Whatever, 180, good. 180 minus 43 minus 57, which is 80 degrees. And I heard we were going to find little a, so I'm going to find that one first. Using law of sines, and I already see that we're going. So I'm going to do sine of 43 over a equals sine of 57 over 12. 57 over 12. Okay, perfect. All right, cross multiply. A sine 57 equals 12 sine 43. Sine 43 divided by sine 57, and I get 9.8. Anybody questions yet? Okay. Now that I have little a is 9.8, can someone set up my area formula for me? Good. Good. Good.
Does it matter which side you do?
It does matter which sign. You have to do the one in between those two sides. So which angle is in between those two sides? 80. Very good. That's a good question. It does matter which angle we use. Yeah.
I use a different like sign for the last one. Like I did sign 43 over A, sign 80 over 12. Then I got 8.
Oh yeah, you can't use sine of 80 over 12 because the 12 goes with the b. It goes with the 57. Yep, good question. So, and I tell you that by using those variables. So I tell you big B and little b go together. So that's how we know to use not sine of, yeah. Yeah. Easy mistake to make. So I like that we're just kind of cleaning it up, making sure it goes right. All right, so I'm going to cancel out that 2 and that 12, but it doesn't matter. You can throw it all in your calculator. And I get 57.9. Oh, that's not degrees, that's area. And area is in terms of centimeters squared. Bless you. Bless you. So we had to do law of sines to find that missing side. And then that gave us enough information to do my area. And after we did our area, then we were all done. All right, we're going to do one more like this. Set our triangle up. Oh yeah, of course. You're welcome. All right, I need to find, it really doesn't matter what angle you find, but we need to find at least one. So which law do I need to use now? What'd you say, Andrew? Cosines, very good. We got to use law of cosines. I know if you tried to use law of sines, you'd realize that nothing works because you need at least one angle to do law of sines, and I don't even have one angle to plug in here. So it truly doesn't matter which law of, which cosine angle you find, but we need to find at least one of them. Does anyone have a preference on which one we find? All right, let's do B. Lauren, what'd you say? Okay, good. I was worried that you said something and then Isabel goes, I was going to say B, and I picked Isabel, and I was like, ooh. Yes. Twins. Okay, perfect. All right, so we're gonna do B. Again, it truly doesn't matter if you did A or C, you're gonna get the same area at the very end. So I'm gonna do B. I will do 12 squared equals 10 squared plus 16 squared minus 2 times 10 times 16 times sine of B. So 12 squared equals 10 squared plus 16 squared minus 2 times 10 times 16 times cosine of big B. Okay, I've gotten this far. What's my next move? What can I do next? Leave the cos, get the cosine B alone. How do I start getting that cosine B alone? Good. Can I add negative 320 to that? Okay, no, good. That is such an easy mistake to make. So I just want to keep like bringing that up because I don't want us to make that. So I've got 144 equals 356 minus 320 times cosine of B. And I'm immediately going to minus that 356 so I don't get too confused in my head. So 144 minus 356 is negative 212 equals negative 320 cosine B. Let's divide that negative 320 off of both sides. And then what's my last step to find what B is? Inverse cosine, very good. Oop, that was the wrong button. Second cos, answer. And I get 48.5. Okay, B is 48.5. Okay, are we done or do we have another step? Another step. Now what do I need to do? I'm gonna do my area and I'm gonna plug in.
16 to 10, 48.
That's what we're gonna do. Oh, I'm so sorry. Area. I think I said we're just doing area now. So now we're just gonna plug it into that area formula. But yeah, you made a good point. Jack's like, we don't need to solve anything else. Stop, pause, do not pass go. We're almost, Jack's like, we're almost there. Just finish the problem. So yes, at this point, I don't care about anything else. All I care about is, ooh, A, not writing 10 twice, and B, plugging it into my area formula. You good, Iz?
No, but we're in the one that says A and B. It doesn't matter.
Remember that you just need an angle and then the two sides next to it. So the angle that we chose to find was B, which means that I'm not going to use little b in my equation. I'm going to use little c and little a. Can't type anything right. Nope. All right, I got 49 or 59.9. Is that what you guys got? Okay, perfect. If you got something a little bit different, or if you solved a different way, you might be like a little bit off on your decimals. Just make sure you're careful and show enough of your work. And if you're off by like a 0.0 something or a point something, I will see your work and I'll see that it's fine. Okay. All right, so we're going to jump to the next page. We're going to skip letter D because it's just like letter C. So you can try that one on your own later. But I just didn't think we needed to do another one just like what we've done. We are going to do on this next page, we're going to do A, B, and C. And I really don't feel like doing D today, so don't worry about that one. Bless you. So I'm going to do 3 like word-ish problems, and then that's it for today, and that's it for chapter 5. Cool? All right, so on Wednesday.
You don't have school that Friday?
We do have school that Friday before. I think that's an all school skip day. Well, it's the day before spring break. So just like nobody. Tough. It's tough for those spring sports. We don't either. They always do. You guys always have stuff over spring break.
For the first half of the week. Again, that Friday.
And then you get to do whatever you want on spring break. Yeah, we have a game on Thursday. I always schedule a Thursday game if I can.
It's here, right?
It's here.
Is HSC away?
HSC is away. Jacob, do you take good pictures? Like with a real camera?
Yeah.
Oh. I might find a gift card for you if you take pictures at more than one game.
I can do that.
Okay, great. I just like need someone to do it, and like I can't coach and take pictures.
Do you not have the one like
Unless they come, unless I don't pay them.
I think
Yeah, I don't. I've never been contacted by them, so it's who? Oh, Caleb's mom. Oh, I know Caleb. Maybe I gotta get on that. Okay. All right, let me get these 3 problems done, and then we can mess around. Okay. So I've got 3 problems, and they look more confusing, but all they're using is law of cosine, law of sine, and then the area formula that we just learned. So let's draw a picture that's going to help us decide what we're going to use. The first one says, find the area of a regular hexagon inscribed in a circle of radius 12 inches. What is a hexagon? 6 sides. Okay. 1, 2, 3, 4, 5, 6. Perfect. Okay, that's half the battle. A hexagon is 6 sides. Inscribed in a circle. Do you remember what inscribed means? What'd you say, Gabe? It's inside the circle. So the circle is surrounding the hexagon, and inscribed is a certain way that it's not just the circles on the outside. The circle is going to touch all the vertices of the hexagon. So I need to keep bringing in a little bit more. It's a shape inside of a shape, and it touches it exactly. Okay. The reason that's helpful, though, I know we hate it, but I find it really helpful because it says that the radius of the circle is 12 inches. So that means that wherever I am in the middle of the circle, if I go to any point on the outside, I'm 12 inches away. So here I'm 12 inches away, here I'm 12 inches away, all the way around I'm 12 inches away. And it's most helpful to stop at one of the points where the hexagon and the circle are touching. I'm going to make a triangle using 2 of the radiuses and 1 of the sides of the hexagon. Remind me, what's the radius again? 12. So I know this is 12 and that's 12. I want to find the area of this regular hexagon. Well, we just practiced finding the area of the triangle. So if I can figure out what the angle right here is, I can find the area of that triangle. And how many triangles are in this hexagon? 6. These aren't perfect, but I have 1, 2, 3, 4, 5, 6. So if I can find the area of one triangle, I'm going to do 6 times that to figure out what the area of the entire hexagon is. Okay. Let me redraw my triangle out here just so we can kind of get a better picture of it. So we know each leg is 12. We don't know what the base is, but I don't care. I do need to know what this angle is right there. Now this hexagon is inscribed in a circle. How many degrees are in one circle? 360. And how much of 360 am I using right now? A sixth of it. So what's 1/6 of 360? 360 divided by 6 is going to be that angle right there, because I split my 360 into 6 smaller spaces. So this angle is 60 degrees. A lot of it's kind of like this mental stuff. Like I don't have a lot of work because I'm just kind of like working through it in my head. So I took my hexagon, I split it into a triangle, and the sides are 12 and 12. And then I know what that missing angle is because I have 6 triangles around here. So I did 360 divided by how many triangles I had to find that angle. Can we find the area of this triangle right now? Yeah. 1/2 times sine of 60. Very good. Am I zooming too much? I'm so sorry. Sometimes I feel like I'm going so slow, and then sometimes I think I'm doing fine, and you guys are like on your paper. So area for one triangle is 62.4. But I don't care about just one triangle. I want to find it of the entire hexagon. So I need to do 6 times 62.4. And so area of the entire hexagon is going to be about 374.4. And I think we're in inches squared. I'm like 95% sure there's one like this on the test.
I just feel like I'm not gonna like remember all these steps, like all the little mental math.
So it's I'm gonna give you guys a study guide today because I see you today, and then I see you Monday, and then your test is on Wednesday. I guess it's not back to back. I thought you guys were back to back, but I'm gonna give you guys a study guide today if you want to start preparing for this test. There's a lot of problems on there, but like this isn't that hard. But if like you don't remember all the little steps, it gets hard. So I want you to practice, because I'm like really sure this is on the test. All right, the next 2 problems, that was just an area example. The next 2 are using law of cosines. And once we draw a picture, it's just a pretty easy law of cosines. Okay, you guys ready to do the next one? Another flashback to geometry. It says a parallelogram has sides 18 and 26. Do you remember what a parallelogram is? It's like a slanted rectangle. Brother. Yeah.
He actually gets it like
7276.
It could be like a mistake, or he'd like really be trying to mess with me because sometimes he does stuff like that. Stop.
you can just pick him.
Class is over. Someone just skewed.
It's my order.
Wow.
He was like, I don't care.
I thought you guys were all in the same religion second semester senior year, except for this kid. Who's what? They're mine to give to you guys. I brought him to practice yesterday. You guys didn't eat them. Okay, Lauren did have one. I literally had like 5 kids took one. Of our like 20-person team, only like 5 people had one.
I didn't grab a cookie, but I grabbed this.
Okay, good.
I wasn't really feeling cookie.
Well, it's almost 11 in the morning today. You can have a little tiny cookie. Brother, get off. There we go. Okay. Yeah. Let's hurry. He might get back on. I'm just kidding. Okay. So it's a parallelogram, and it says sides are 18 and 26, which means that the 2 sides that are parallel to each other are the same. So we'll say these 2 are 18. And then the other 2 sides that are parallel are also congruent, which means those sides are 26. This problem also says that it has an angle of 39. My other class Class kept asking, like, where does the 39 go? I would just put it in the acute angle spot, right? There's an acute angle right there, so I just would put the 39 right there. It would be over here as well. And then it says find the shorter diagonal. So diagonal is where we draw a line across the center. Which one's going to be the shorter diagonal? Is it going to be this one right here? Or is it going to be this one right here? The second one. I don't really have a great reason for you besides the fact that the side across from the smaller angle is going to be smaller. But like my other class was like, well, it just looks smaller. That's a good enough reason right now. This does look smaller. It is smaller. So I'm going to find this missing side. We'll call it X. How would I do that? Good. I've got like a little triangle right here. And what law do I need to use to find X? Can I do law of sines here? I don't think so. Law of cosine.
Yeah.
You walked in.
Yeah, but I can tell. I can already tell.
Why can you tell?
Yeah, exactly.
Oh, one angle, two sides.
What I've got a side, angle, side. Anytime you see side, angle, side, I want you to do law of cosines. If you tried to set this up in law of sines, it just wouldn't work. Like it wouldn't match up. You wouldn't have an angle and a side because then I would be trying to use this set and I don't have another angle there. So I have to use my law of cosines. So that's one thing I like about law of cosines and law of sines is like you physically can't use the wrong one. All right, so I'm gonna do x squared equals 18 squared plus 26 squared. Don't fall apart yet, we're almost done. 2 times 18 times 26 times cosine of 39. I'm zooming so I could write that nicely and now I can zoom out. And this is actually the easiest way we can do law of cosine because I could almost put all of the right side into the calculator and then do a square root and call that a day. We're gonna do that one. It's gonna be easy like this one. X squared equals, you know, I like to do it in parts, but if you can do it more together, you can do that. Thank you. 727.4. You can combine all of those together. Don't mess around with that. Do you do 2 times 18 times 26 times cosine of 39? Yep. So since we have a number for cosine 39, you can do that too. And now I can combine them all together. $324 plus 676 minus 727.4, and I get 272.6, and then we just square root, and that's my answer. Oh, that's not it. I get 16.5, and that's in terms of feet. We just have one more to do, and it's just like this one. And they even already drew the shape for us, which is really nice of them. Anybody have any questions on this before I move to the last problem for today? Yep, I'm gonna leave it up here for 1 second.
And which one did you use? Did you use like a square?
I think I used the a squared one. It doesn't really matter how you label it. I've played around with how I've given you guys law of cosines in the past because sometimes I just give you one and I tell you to just kind of maneuver it on your own. But this year I gave you all three because I think it can be helpful. But if it confuses you, you can just use one of them. They're all the same, just kind of rearranged. All right, last one. It says Tony must find the distance from A to B on opposite sides of the lake. So we're finding this side right here. and it says he locates a point C that is 860 feet from point A and 175 feet from point B. He measures angle C to be 78 degrees. Find distance AB. So this is literally like what we just did, right? The exact same problem, another really easy law of sines. We'll make this my C. This will be my little b, that's my little a, and this is angle C. So plug and chug. I'm going to give you a second to try that on your own. Ooh, these are going to be big numbers. Okay. I'm going to do those two together. So 860 squared plus 175 squared is 770,225. And then I'm going to do 2 times 860 times 175 times cosine of 78. And I get negative. Okay, so that makes this positive 3, 1. Oh, no. I miswrote that. 2 times 180 times 175 times cosine of 78. Okay, that's better. Okay, so it's minus, not plus. 62581.4. Subtract those two numbers. Do I not subtract them?
Oh, wait, never.
I think when I did these multiplied together, I got a positive number and I kept the subtraction sign out here.
And you have 4.
I have the wrong thing.
You just need to do it.
I just need to, it's okay? Okay. I think my decimal is off though. I think that's better.
The first number should be 770,224.
224? Okay.
Oh wait, I
Oh.
the wrong number. It's 225.
Okay. Okay, so I think I get 707,643.6, and I think I have to square root that, and now I think I'm done. The hardest thing about this was just the big numbers were like a little like not natural for us. Okay, yes, and this is what we got last period, 841.2, and I believe this is in feet again. Whew, okay, we did it. These are giant numbers, so that's why it was kind of weird. Okay. I'll leave it up there for you guys in class. For those of you watching online, that is it for chapter 5.6. We're reviewing next class and we're testing after that. Come see me if you need help.